Hello and welcome. Welcome to this computing fundamentals topic. Remember, this is our first topic, and like I said, I expect that you had gone through it in the last semester when you look at principles of computing. So my name is Dr. John Karitha. I'm the one taking you through this course, BEC 121, Business Computing, together with Mr. Waweru, who is taking another group. I think my group is B100 and B103. Then Mr. Waweru is taking B106, but we'll be synchronizing on that. So let's start and look at the fundamentals of computing, starting with the definition of a computer system. So what is a computer system? So a computer system is simply an integration of hardware, software, data, procedures, and the users, the people who use the computers themselves. So that is what we call a computer system. You may ask yourself, why are we including people here? You cannot keep a computer there and it is going to do things by itself. You need to go there, type something, click here and there. So that is why people are put there as part of the computing system. So let us start with the hardware, just a basic definition. The hardware refers to the tangible components, the things that you can see and touch in a computer. Things like the keyboard, the monitor, the CPU itself, that big box, the hard drives, and so on and so on. And this is where we have the processing capability of the computer. We have the software. These are programs and instructions that direct hardware operations. So they direct hardware operations. And they are divided into two softwares. We have what we call system software, which includes the operating system and drivers. We are going to look at that in more details. And application software. This is what you actually use. Application software is what we actually use. The word processor, you go there and open Google Chrome. You want to type something in Excel. You want to edit a video on GIMP and the others, and so on and so on. We have the data. These are the raw facts and figures, like the number, text, and whatever. For example, when you open a Word document and you start typing, what you are entering in there is data. So this data becomes the information after it has been organized. You have to enter it on your computer, organize it in a nice way, process it, and give it context. We are going to look at that in more details. We have the procedures. These are rules and guidelines governing system use. For example, how do you enter your data, and how you organize that particular information. And finally, we have the people who are using that. Includes end users, people like you and me, the IT professionals. When you go to the computer lab, you'll find those lab technicians there. IT managers, like in the university, we have the ICT director. These are the people who operate and interpret system outputs. So people are very, very critical because technology is as good as when people use it. So there is no single component that defines a computer system. So a computer system is a series of all these come together to do something and come up with outputs that can be consumed. Next, we look at the information processing cycle. What is the raw input? Remember, every time you go to, even in a factory, we start with raw materials. They are taken through the system, through the processing. Then finally we have an output. Think of the tea leaves that we have there. You see them there, they are green in the farm. Somebody has to go weed them, water them if they have to be watered, harvest, take them to the factory. The factory does its thing. Then when you go to the supermarket, you find something that is packed there. So you don't take the green leaves yourself and start processing them yourself. So there is a whole process that takes the tea leaves until you have what you get in the supermarket. The same thing with coffee, the same thing with maize flour, and so on and so on. So similarly, when you see something well organized, like what we have here, my slides, you see my slides, I took quite a lot of time to gather all the information about this particular topic, put them together, generate these slides that you can see the way they are. So it is a process. So this is what we call the information processing cycle, like what I have done here, producing these slides. So it is the core functional model of all computing system. Every task that a computer performs, like sending email and simulating some data, follows a four-stage sequence that we have here. So usually we have an input, which is processed, becomes an output, and that output is stored somewhere so that it can be shared with other users. So this cycle is continuous and iterative. You could start with an input, do processing, get an output, store it somewhere, then you look at it, you realize, this is not what I wanted. So you start again. So it could be iterative, it could be repetitive until you are happy with what you see. A good example is when a bank teller enters a transaction. When you go to a bank, you tell them you want to withdraw money. They put in how much, what is your name, your ID number, how much do you want to deposit. Supposing they made a mistake, you said you wanted to deposit 5,000, but they put in 500. They have to repeat the process again so that they update your balance. So that cycle is iterative. The idea is that you repeat it until you are satisfied with the result. Next, we look at types of computers. And basically we have several categories. We have what we call personal computers, enterprise systems, and cloud-based systems. So there are three categories basically. Let us look at personal computers. Personal computers are the ones that you have there. Things like your desktop, the ones that you have in the library and in the computer lab, and what we call laptop computers. A laptop computer is a much smaller thing. You people should know what a laptop computer is. So it is portable, but desktop computers are stationary and they come with different components. That's a good thing with desktop computers. You have a big box that is a processing unit. You have a separate mouse that you can remove and insert. The keyboard is also comes separately. You can remove it and insert. Unlike a laptop computer which is portable, and all devices are integrated together. It is not easy to remove the keyboard of a laptop. It is removable, but it is not something that you can remove and plug back on the go. So these are the most widely used kind of computers. I'm sure some of you have them, but they have some advantages and disadvantages. Like I said, they are widely available because they are affordable. They are not very expensive. They are used for general purpose. For example, processing your documents, spreadsheets. When you want to do group work, I'm sure you use those computers. The disadvantage is that they have moderate processing power. They don't have a lot of processing power. So if you have a lot of data, you could face a challenge doing that. We have the second category of computers, which is what we call the enterprise systems. These are used for handling large-scale operational demands of organizations. Think of a bank like Equity, or think of a Safaricom. They cannot use a laptop even to handle Fuliza alone, because imagine how many people are using Fuliza every single minute in this country. So it becomes very difficult to do that. So they have to use more powerful computers, what we are calling enterprise systems, that can be divided into two. We have servers and mainframes. A server is simply a dedicated computer that provides services to other machines or clients. Think of an ATM. When you go to an ATM is basically a basic computer. When you enter that data there, I want to withdraw this amount of money, it is sent to another dedicated computer called a server, that is the one that executes those transactions and then returns the information to the ATM. We have mainframes. These are extremely powerful computers designed for bulk data processing at massive scale. So data processing at massive scales. For example, if you look at organizations like Google, NASA, and so on, the ones that have a lot of information they need to process at a go. So they use what we call mainframes. So the key differentiator is that enterprise systems are optimized for multi-user, high availability, and mission-critical operations. So these enterprise systems, servers and mainframes, they are used for in cases where there are many users using the same data at once. You need high availability. Think of how angry you'd be when you go to an ATM and it tells you we cannot give you money because computers are not working. That is what we mean by availability. They need to be available almost throughout. And mission critical operations. Like you saw the other day, people went to the moon, I think the dark side of the moon. So that is a mission critical operation. You cannot use a laptop in that case. You need a serious computer that will process data very, very fast. The third category, we have what we call cloud-based systems. In many cases, you have a laptop, but you want to process a lot of data that your laptop cannot handle as an individual sometimes. So you have two options. Will you go and buy a mainframe? A mainframe is several million shillings. Will you go and buy a server? Most likely you don't need that because maybe you are processing this data once off. In that case, you can just log into your computer, go to something like AWS, that is Amazon Web Services, or Microsoft Azure. You can hire a computer online. You process your data online, you get the results, then you get out. You don't need to own that computer yourself. That is an example of what we call cloud-based systems. Those are what we call cloud-based systems. The good thing is that you can get them on demand. Like I said, probably you are just processing data for your research once in a year. You don't need to buy a mainframe. Just go online, go to AWS, buy a computer for 2 hours. They charge you even hourly. Process what you want to process, then get out. They are scalable. Scalability means if you want more processing power, you simply pay more money and they give you more processing power. You can access them remotely. Like I said, you just log into your computer, go to AWS. You can just go and type AWS. You are going to see them. Let's see that AWS. So this is what we call a cloud computing platform. So it is usually one of the best way for you as an individual if you want to do a lot of processing, which you don't do often. You don't need to buy a big computer. Just go to AWS, Microsoft Azure, and hire that computer and access it online. Next, we are going to look at hardware components. We have the hardware, we just looked at it. These are the physical things that you can see and touch. And for a computer, there are basically 3 major components, what we call the control unit, the ones that direct the overall operation of the CPU. So it fetches the instructions from memory. When you type something, it is a CPU that is going to handle that. We have the arithmetic logic unit. This is the computational engine of the computer. So it performs all arithmetic operations, comparisons, and so on. Then we have registers. These are extremely small, ultra-fast storage locations built directly into the CPU. So it holds the data that is currently being processed. So those are the 3 components. Now, let us narrow down to the CPU itself, what we call the central processing unit. How do you measure the performance of a CPU? And this is something that you should be worried about. This is what you look at when you are buying a computer. You look at its clock speed measured in gigahertz. You will see 3.5 gigahertz to 1.7 gigahertz, 1.2 gigahertz, and so on and so on. So this is the number of instruction cycles the CPU can execute per second. So how much data can it process per second? What is the speed? How much can it do that per second? Then we have the number of cores. These are independent processing units called cores. So inside the CPU, a CPU could have more cores, which is better for you. Then we have the cache memory. This is what we talked about here, registers. So this is a small bank of ultra-fast memory embedded near the CPU, which stores frequently accessed instructions and data. So in this case, when you are buying a computer, you should look for a computer that has a higher clock speed, higher number of cores, and higher cache memory. You are going to see these three things when you are buying your computer. However, a faster CPU doesn't mean it is a better computer. So a good computer will depend on the balance of CPU itself, the RAM, and the storage speed. So you can have a computer with very high clock speed, but your storage speed is low. We are going to see at what we call storage speed, and your RAM is small. Then you are going to have problems still. So a good computer is a balance of all these three. You have high clock speed, higher number of cores, higher cache, enough RAM. You're going to see what RAM is, and good storage speed. That hard disk should be fast so that data can be fetched in and out of the storage as fast as possible. We have the concept of RAM, which is what we call the working memory. In accounting, you looked at something that we call working capital. So RAM, which is what we call the random access memory, is temporary high-speed workspace where operating system, running applications, and active data all reside while the computer is on. So the RAM is where the operating system, any application you open is running through the RAM, and all data that you are working on, they are going to reside there so that you can work on them concurrently. Now, once you close your computer, everything in the RAM is erased. That is why if you open a Word document, write your name, then just close your computer without saving it, you lose your work. Of course, in these cases, we have the concept of document recovery, but in many cases, you're going to lose your work. So it is very fast, the RAM. Volatile, that is, if you don't save it, your data is gone. Multitasking, so if you have more RAM, you can run more programs. I'm sure you have come across a scenario where you open very many programs on your computer, then it crashes. That tells you it has the RAM has been exceeded. The capacity, so you can get as much RAM as you want. Nowadays, if you are buying a computer, I would suggest you buy a computer with not 8 GB, 16 GB RAM and above. So you can have 16, 32. I'm working on 32 GB myself, the RAM on my computer, 64, 128. If you have more, if you need more capacity, you can even have more than 128 GB RAM. So the better the RAM, the more the RAM, the better for you. So you can upgrade RAM in case you find your computer is hanging a lot. One of the best solutions is to upgrade your RAM. Of course, you have to check whether how much capacity of RAM your computer can hold. But if your computer is hanging a lot, most likely you need more RAM, especially with Windows 11. A lot of computers are suffering. They cannot handle this. The operating system, Windows 11, is too big in itself that computers are suffering. So if your computer is very slow, or in many cases, try upgrade your RAM and see what you're going to do. So RAM is like your desk. Your desk is where you put all those things that you are working on. You work on them. Once you are done, you store them somewhere, remove something else, put it on your desk, work on it. So it is like your working desk. So we have several types of storage devices when you want to store your data now. Remember we said RAM is just temporary memory where you work from. And in case you close it, you lose all your data. However, after working on your document, for example, you will need to store it somewhere. We have several types of storage devices. What we call a HDD. HDD is the one that used to spin. It was had magnetic plates that were spinning. Quite slow. It was quite slow. So again, if you want a good computer, make sure it has solid state drive. A solid state drive does not spin. It is like your hard disk. I mean your flash disk that you use. It is solid state. Your flash disk doesn't have things that are spinning there. You can imagine a hard disk drive. Every time you want to access something, it has to spin until it gets to where your document is stored. But a solid state drive is much faster. Then we have external storage devices. We know them, the USB flash drives, external HDDs. We also have external solid state drives that are in the market nowadays. So in this case, if your computer is full, you can buy an external storage and you remove some of the content in your computer, put it in the external storage drive and see what you think about. We have input devices. This one is something that you must have looked in the last semester. These are just examples of a few of them. The keyboard is a very common input device. The mouse, most computers have those two. A scanner, usually this is something you have to buy on the side. A microphone, many computers nowadays, especially laptops, they have an inbuilt microphone that you can always use. So input devices are used for inputting data into the computer. They are for inputting data into the computer. If you want to type something, use a keyboard. Mouse is for clicking. A scanner is for scanning documents. A microphone is for inputting sound, and so on and so on. We have output devices like the monitor, the printer, if you want to print a hard copy of something, a speaker, if you want to listen to music. Music is audio output. So output devices give you an output from the computer. If you want to listen to music, for example, you have that. Finally, we have peripherals. These are external devices connected to the computer to enhance its functionality. Examples include external hard drives, webcams, projectors. We use projectors a lot in class, and graphic tablets. For example, when I'm teaching a class, I could use a graphic tablet to write some illustrations. So when you are buying a computer, what are the hardware performance considerations? We said ideally you should look for a computer with higher RAM. When it comes to storage, please choose a computer that has solid state drive. A solid state drive is faster. Number 3, look at the clock speed. The higher the clock speed, the better. Look at portability versus power consumption. Of course, for a student, a laptop is better. You don't want to move around the university carrying a desktop every morning and evening. A desktop is better for you because it is portable, computes less power. Then current needs. What do you actually need? So don't again buy a big thing that you really do not need to use. For a student, for example, a laptop with 16 GB RAM, maybe 128, 256 or 512 GB ROM, what we call read-only memory. Remember, it has to be SSD so that it is faster. And That mostly will be enough for you, and maybe a clock speed of around 3 gigahertz and above, you are good to go. But if you are working as a data analyst, for example, you'd need much more. You'd need like 32 GB RAM, maybe 1 terabyte SSD hard drive, maybe 5 gigahertz speed, and so on and so on. So those are some of the things you need to look at, even your use case. So don't just buy a big computer that may not really, you could be wasting resources because you are using very little of it. So look at your use case. Do I really need this? What is the basic minimum that I need? So for a student, you don't need such a big one as a kid. So we looked at hardware. Now let's go to the software components. We said software is divided into two. We have what we call the system software and the application software. So the system software operates as the foundation of the computing stack. So it communicates directly with the hardware. So remember, we have the hardware. You have to have a system software that communicates with the hardware and also communicates with the user and the applications. So this is what we have. And we have three types of them. We have operating systems. In many cases, most of us use Windows. That window is the one that you open, and it opens fast before you open any other document or any other application. That is the operating system. So that one communicates with the hardware directly and also with the applications and the user. So Windows 10, Windows 11, we have Mac OS. People who use these expensive computers called MacBooks. So they use an operating system called Mac OS. There's Linux. Linux is an open source. We have Android. Android is also an operating system. It is very, very common in phones. Most phones in the world, I think around 70% use Android. So that is an operating system in itself. So we have device drivers. So these are specialist programs that allow the OS to communicate with specific hardware. For example, when you buy a new printer and you install it in your computer, you have to install a specific software that allows your computer to communicate with this printer. That is an example of a device driver. Even when you put a USB stick, it has to have a device driver, and so on and so on. Finally, we have utility programs that do maintenance and optimization. For example, disk defragmenters, antivirus, backup utilities, compressors, system monitors, and so on. So the system software is largely invisible to you. It runs in the background. It is the one that manages resources. It manages the hardware and it manages the applications so that you have a smooth idea. So examples include Windows, like I said, Mac OS, Linux, and so on and so on. We also have FreeBSD and the others, and they are there for you to try them out. One thing you realize, Windows, you have to pay for that license. Usually it comes bundled with your computer. Mac OS also, I think that is free, but comes bundled with the computer. Linux is completely free. The last three of them here, Linux and its various flavors. We have many flavors of Linux. Ubuntu, we have Fedora, we have OpenSUSE, and the others. They are mostly free, and that's the advantage of Linux. It's free, but many people say it's hard to use. I'm not sure about that. We have application software. This is what serves you as the user directly. When you open your computer, you want to listen to music, you have VLC, music player. That is an application one. You have a word processor, you have a spreadsheet software like Excel, you have a web browser like Chrome or whatever. Those are application softwares. So we have an extended type of application softwares. All these are even business softwares that we are talking about. All these are application softwares. We have a specialized application softwares like ERP system. These are comprehensive software platforms designed to integrate and manage all core business processes of so that we have a single source of truth. For example, at Karatina University, we have an ERP, a single integrated software that combines everything in the university. When I want to key in marks, I go to the ERP and key in marks. When the finance officer is paying salaries, they use the same ERP to create salaries. When I apply for leave, I use the same ERP to do that. So it is an integrated software that is used for managing organizations. Remember, and it makes things very convenient. Before the ERP came at Karatina University, we used to have a lot of problems. When I'm processing results for students, I go to Excel, process my results separately. Another school process their results separately. There's no way of having a unified platform where all the results can be processed together. Today, we don't do that. We process all the results together. And Karatina University specifically uses Microsoft Dynamics Naves 365. This is the ERP we use, but there are many other versions: SAP, HANA, Oracle, and so on and so on. We also have the CRM software. All these are application softwares. So this one is used for customer relationship, CRM, customer relationship. So managing relationships at scale. For example, those people who are call agents at Safaricom. When you call them and you tell them your phone is hanging, they are looking at what we call a CRM. So they ask you for your number, your ID, whatever, then they tell you when was the last time you keyed in your whatever, and so on and so on. We have accounting systems. These are softwares specifically meant for accounting purposes: payroll, financial reporting, computing taxes, and whatever. So examples are QuickBooks. QuickBooks is what I have used extensively. We have Sage, FreshBooks, and so on and so on. So instead of having all these, instead of having a separate accounting system, having a separate CRM, it is always better to have an ERP. An ERP integrates all business processes into one. If it is payroll, it is done there. If it is marks, there. Results, it is done there. If I want to apply for leave, that is human resource, I do it there. If I want to apply for medical referral, I do it there. Everything there. If I want to apply for transport using the university buses, I do it there. So that is the advantage of an ERP system. It is unified. It is unified. It is better to have what we call an integrated information system like an ERP, because it eliminates silos where data is separated so much. People in transport have their own data, people in HR their own data. When the VC wants to see what is happening within the organization, they cannot be able to tell because data is siloed. It is so separate from there. Another issue we need to be aware of is the question of software licensing. Some software you have to buy it. Like I told you, Windows, you have to buy it. Usually when you buy your computer, part of the cost of that computer is buying Windows. Usually I don't buy a computer with Windows because I don't use Windows myself. I buy a computer without an OS. I just install Linux because it is free and quite easy to use. And you are going to save around 10,000 shillings out of that. So be aware of licensing. Some computers have licensing and you need to do that. Other softwares are free to use. They are what we call open source software. An example is what we call their Linux. And Linux now and Android, those are operating systems. They are free to use. You can just download it and install without worrying about having to pay. Application softwares that are free to use are Mozilla. Mozilla is free. LibreOffice is the alternative to Microsoft Word. Quite a good one. So if you don't have Microsoft Word or it is messing you up, just install LibreOffice. It works quite well. Python, WordPress, and so on and so on. There are literally thousands and thousands. Even the software that I'm using to record this video is open source. It is called OBS Studio. You can just download it, do it, and it is better than most of those softwares that you pay for. We have what we call software as a service, SaaS, another way of licensing. So this is a crowd-based delivery model where software is hosted remotely by the vendor and accessed by the user over the internet. So software as a service. So think of something like Google Docs. You cannot install Google Docs on your computer. You use it over the internet. That is an example of software as a service. And most of Google Docs is free, but there are some things that you would need to pay for. If you want more functionality, you pay a subscription fee, but most of this is free. So Google Docs is a good example of free software. So you are going to look at these comparisons here. We will look at the operating system and what its function is. Like we said, the operating system is what interacts with the hardware directory, and the applications on the other hand. It is like a go-between the applications and the hardware itself. So it does process management. So it determines which programs will run, for how long, in what order. It allocates RAM. If you have memory in your computer, it is the one that is going to allocate. So file system management. So it organizes files in your memory. It manages all inputs and output devices. So it is the one managing the hardware that you have. That is the monitor itself, the mouse, the scanners, the printers, and whatever else. And provides a user interface. The user interface is that nice screen that you see there telling you welcome, and it has a start button on there, whatever. That is what we call a user interface. So that one is provided for by the operating system. So these are the dominant operating system. So we have Microsoft Windows, Apple, Mac OS, Linux. And be careful about Linux because we have very many versions of Linux. So Linux is basically a kernel. If you want to install Linux, just type Google on your computer, Linux versions. So there are almost 100 of them. Personally, I use something called Fedora. Then we have Ubuntu, we have OpenSUSE, we have Zorin, Debian, Red Hat Enterprise Linux. There are so many versions of them, but they are free. Like we said, the bottom two are free. They are open source, in other words. We have what we call file systems. How does the operating system organize and store and retrieve data on a storage device? So we have very many versions depending on what operating system you are using. The oldest one used to be FAT32, but it is very nice because it is compatible. In many cases, if you come from Linux or Mac OS and you are using another version of file system, you store data, you just save data in your flash disk, then go to Windows. You realize in many cases it will not work because Mac OS is using APFS, Windows is using NTFS. Those are two different ways of organizing your file. But if you use FAT32 is compatible with most operating systems. You can just use FAT32 on your Mac OS and you do that. So it is good to know there are different ways of organizing files. And every operating system could have a different way of organizing those files. And that is why you take your computer from somebody who is using Mac OS, you put it in your Windows, you realize it is not working, then you are like, my flash disk is bad. No, it is simply because Mac OS uses a different file management system from Windows. So we have the concept of directories and a folder. So we are going to use these names interchangeably. Think of a directory as that file that you have. A file that you have. Then inside that file, you put your documents. Think of your documents as your Word document, your assignment from this course, assignment from the other course, and so on. So a folder is is an organization unit where you put in all your documents. So you have to document those. You have to be very careful a lot. You have to distinguish between what we call a folder in a computer and a file. Those are two different things. A folder is where you hold your files inside. Think of files as documents so that you're not confused. So a folder is a big thing where you store your files inside. And we could see a few examples when you do our Q&A in the next lesson. So how do you organize your files in your computer? So organize your folders, in our case, into a logical folder structure. For example, you could have one folder that talks about courses. Then inside that you have Back 121, Back 122, Back 123, Echo 110, and the others. Inside that you could have semester 1 and semester 2 and so on. So separate them by function or project and have a consistent naming structure. So don't call it number 1, number 2. Nobody will know that. A good example is this what we have here. You can have a department, topic, and then the year, the month, the date. For example, in your case, you could have classes. Inside that you have year 1. Inside year 1 you have semester 1 and semester 2. Inside semester 1 you have all the courses you did in semester 1. Inside semester 2 you have a folder for all the courses you did in semester 2. And inside each of these folders, now you put your files. Is there an assignment you did? Put it in the particular folder. So this is a question of naming conventions. I want you to look at this. Please make sure you have good way of naming your files. Don't call it report, because after 1 year you will not know what this report was all about. So you could say Back 121, introduction to computing assignment, something like that. That is something more useful. As we conclude, let's look at version control. This is something that messes people a lot. Version control. How do you manage multiple versions of a file or a document? For example, you are given an assignment. You did it up to some point. Then you decided, now I don't like this one. Let me create another version of this file. So the first one was assignment 1. The second one you call it assignment 2 final. You copy another one, you call assignment 3 final. So how do you handle these changes in documents? How do you track changes? How do you track changes in your documents? And how can you revert to an earlier state if you need to? For example, you may have had a document today, but maybe you messed up. Then you realize, I want to go back to the document I had yesterday at midday. So that is the concept of version control. How do you control the version of your document as you update it as you go? So a version is a saved snapshot of a version at a file, at a given point of time. So how do you do version control? Like I said, I want to repeat again. If you have a document, you have been working for it for the last 3 weeks, and you decide today I want to go to the version I have today, I don't like it. I want to go back to the version I had yesterday at midday. That is version control for you. So how do you go back to where you are midday? Do you go deleting word by word? Or do you save at the end of each day, you save that file, give it a name and a date. This is the file as of this date. Then today evening, save it again, give it another date, like that. That way, if you want to go back to the version you had yesterday, you have that file there. That is an example of what we call manual versioning. We also have what we call cloud-based versioning. I would recommend this one to you very much. If you use Google Docs, it has a very good platform where you can go back to the version you had yesterday. You just click on a button there, tell it I want to go to the version of the document I had yesterday at 12:31. It is going to take you back there. It is just going to open that document where you were yesterday at 12:31. So I always encourage students, Google Docs is very, very good. We also have dedicated version control systems like Git and GitHub. These ones are a bit advanced for you unless you are interested in doing that. But for you, I would just say use Google Docs, even Microsoft Word nowadays and Microsoft Excel. We have those online version. If you just go Microsoft Word online, it is just going to open an online version of Microsoft Word that you can use. The good thing with that is that if you want to go back to yesterday's work, you can simply click on a button there. I want to see the version of this document as it was yesterday, and you are going to get there. So that is good. So it prevents data loss. The idea of version control enables collaboration, maintains audit trails. You can be able to see how you have updated your document as you move that, and most importantly, it supports rollback and recovery. You can go back to the version that you had yesterday, and so on and so on. So as we conclude, we will say that the real value of a computer system lies not in any individual component, but in how they work together. The hardware, the software, the people, and the processes, and so on. They have to work together. In many cases, nowadays, we are moving towards what we call integrated systems, like the ERP, because they enable us to, at a glance, see what is happening in the organization. So with that, I want to bring that to a close. We are going to have a practical lab where we look at all these things. What is a file? What is a folder? What is this? What is that? And I'm sure you'll be happy to see how it all works out. So thank you very much.